So here's the deal. Every living cell occasionally produces things that are toxic. Reactions happen, and you get products you need, but maybe you get byproducts, side products that aren't good for your cell. And generally, your solution to that, to the fact that your cell makes stuff that is toxic, is you make more enzymes, right? You make enzymes that'll break down or inactivate or detoxify whatever it is that could hurt your cell. One of the easiest examples for us to look at of an enzyme like that and of a byproduct that's toxic like that is that all living cells at certain points create what's called hydrogen peroxide. And the formula for hydrogen peroxide is what? H2O2. One more oxygen than water, right? And yet somehow that thing is actually toxic to living cells. It's also very useful to humans, right? We use it to disinfect things. You can use it as mouthwash. You can dye your hair with it. It's really strange stuff. But so your cells produce this, and you have to make an enzyme that gets rid of it. The enzyme that you happen to produce to get rid of it is called catalase. Okay, so catalase basically takes hydrogen peroxide and changes it chemically into water and oxygen. However, obviously this isn't exactly how it works, because why? What's wrong there? What's wrong with that equation?
There's one too many oxygen.
Yeah, there's an extra oxygen. There's only 2 on this side, and there's 1, 2, 3 on this side. So that must not be exactly how it works. What do we have to do to figure out how exactly it works? What do we call that when we figure out how to make the numbers add up? How many molecules of peroxide does it actually take to make how many molecules of water and oxygen? What do we call it? Didn't you have to do that last year? Didn't it give you nightmares? No? Balancing equations? Because that's what it's for. The only reason we balance equations is to establish, okay, it takes this many molecules of this to react to make this many molecules of the product. And so what you're going to have to do now is, you see that, do you remember how to balance? Raise your hand if you think you kind of, I'm not going to put you on the spot. Do you kind of remember how to balance equations? Whoa, not many. You really just have one tool, and the tool is called a coefficient. And the coefficient goes, well, you have the lines already. I'll put them up here. The coefficient you can put in a space just to the left of any of the molecules, right? So I can put a full-size number to the left of peroxide, water, or oxygen. And what that number does is say, okay, this many molecules of that, right? So if I put a 5 here, how many hydrogens do I have now on that side? 10. And how many oxygens? Also 10, right? It multiplies through the whole molecule. That's all there's to it. You just got to figure out a way to get the number of hydrogens and oxygens equal on either side of the arrow by putting numbers to the left of things. Take a couple minutes and give that a shot on your lab. The blanks are there for you. Normally they're not. I just want to make sure you know where you can put numbers. So find that equation and see if you can balance it. And I'll get some stuff ready here. Sorry, I know this is loud. By the way, that is the 3D structure of catalase. I told you, a protein is a big, long, 100-plus amino acid chain folded up into a 3D shape. You can see the level of folding we're talking about. It's a lot. It's like a big old ball of yarn. And somewhere in there, peroxide fits into the active site, right? Did you balance it? I'll give you another minute. Pretty simple as these things go, right? If you're lucky enough to put the number in the right place the first time, you got it. Okay, I'll let you struggle through that later. Take a look at the table you're about to take data. So what we've been doing, Mrs. Andrews and I, to prep for this lab is, first of all, I think she had to go to like 4 different stores to find liver, because They don't sell much liver anymore because of the pandemic. I have no idea why that's a thing. But basically, we've chopped up carrots, potatoes, ground beef, which is already chopped up, I guess, and beef liver, which is super gross, by the way. Anybody eat liver? Never had liver? My parents used to make me eat it when I was a kid. That's probably child abuse. And I actually have two different states that this stuff is in. They're all chopped, but before we chopped them, we actually boiled half of the liver, ground beef, carrots, and potatoes. So we've got basically boiled and unboiled versions of each of these. And what I'm going to do, because all living cells have catalase in them, we're going to test for the presence of catalase by pouring hydrogen peroxide on the chunks. And how are we going to know if there's catalase?
Well,
Why does it bubble?
I don't know. It just says it's going to bubble.
Why? Look at the reaction.
Because there'd be extra oxygen.
O2 is oxygen gas. And so if that reaction's happening, we're going to see it. We are going to see oxygen. We could probably also light it on fire if we wanted to, but I'm not going to do that because I'd get in trouble. So your job, as I hold the tube up so I don't have to kind of walk around the room, I'm going to hold the tube up right up to the camera. You're going to have to kind of judge, and I'd use pencil or light ink at first. You're going to have to judge on a scale of 0 to 10, where 0 is no bubbles and 10 is holy crap, lots of bubbles. What number each of these samples get? I'm going to start with raw. Okay, notice that raw is actually, unboiled is what raw is. It's actually in that third column. And so you're going to start your numbers in the third column. I'll go in order from carrot, potato, beef. Why does it say muscle? Because pretty much all the meat you eat is muscle, with the exception of things like liver. So I'm going to do that. I'm going to put chunks in a test tube and then cover it with hydrogen peroxide, and your job is going to be to judge what level of bubbles we're looking at, which will tell you what level of reaction is happening. Everybody ready?
Yes.
Cool. I use my hands for the carrot at least. So this is raw carrot. Several chunks in there, and I'm just going to go straight from the bottle. I'm going to not spill peroxide on my computer. Definitely some bubbling happening. There's a tiny bit of foam at the top. Maybe better a little further out. So a bunch of bubbles at the top. Again, I would kind of do a tentative number here, and feel free to change it when we see what the other things do, okay? So that's carrots, and I'll come back and show you those later as well. This is raw potato. Interesting, because what's happening on top is different from the carrots, but I don't think that's because of more catalase. I think the starch that's come out of the potatoes into the water is making the bubbles more foamy, making them finer. There's definitely bubbles on top. Almost looks like an ice cream float. Yeah, the starch is definitely changing how it looks, though. It might be a little more than the carrots. I'm getting more and more foam on top. Here's what the carrots look like. Again, still bubbling. Taters. All right, let's try beef. I'll use some forceps for this. hard because the beef wants to clump up, and I want there to be the same size chunks as the carrots and potatoes, but it's not. This is not going to shake out that way. In our next chapter, you'll learn that I'm not managing my variables super well. I should be weighing these out and making sure that it's the same amount. I should have the same volume of peroxide and stuff, but this is close enough for government work. All right. So, beef, here we go. Already seeing bubbles for sure, bigger bubbles. A little more. But again, it's kind of hard because the beef is clumping up and kind of blocking the peroxide from getting into the middle of it, but definitely more than we've seen. Like it's actually moving the beef kind of up and down a little bit, which is gross. Like I'm good at video games, but I can't seem to get it in my head that when I move it this way, it goes the other way on the screen. So dumb. Okay, liver, raw liver. Ugh. Oh my God. All right. Oh, it won't go down. Come on. Okay, you ready? There we go. Again, this is hard because it's all clumped at the bottom. It's not going to get around and below the chunks like it did with the carrot. So we'll see if this works. If you can't tell, that's foam going almost like halfway up the thing. Like the foam went up to here. And if I pour in more, it just does the same thing again. Uh-oh, it's going to come out of the top. Yeah, so that would be a high number. You know, you can reserve judgment as to how high until we do the cook. That's fine. But that's what that looks like. I'm going to get a tissue. Cooked. Predictions. More or less, do you think? Or the same? Less? Who says more? Someone said more. Less? Why? Why do y'all think less?
Well, because when you boil, one, it's really hot and it's making the water bubble right there. It's probably going to help at least a little bit and take away some of the oxygen, especially that's inside of it.
You think the boiling is going to take away oxygen and do that reaction for us, or?
I don't know.
Okay. Allie?
Well, I think like when you boil it, it's supposed to like it takes more like the nutrients out.
Ooh.
Than, like eating it raw.
So we've all learned that boiling takes nutrients out of food, and so you think one of those nutrients might be the catalase? Okay, I like it. Let's give it a shot. Here is, this is all the raw stuff. Let's do cooked carrots first. I hate that you guys don't get to do this yourself. That's what I usually do, is have you do it yourself. But I love that I get to do it myself. I usually don't like play along with you guys, but it's fun. Okay, cooked carrots. Well, it's not quite nothing. There are bubbles, but I bet you can't see them very well. They're real tiny. Tiny bubbles. Less than we saw with the raw for sure. Let's see if potatoes holds that pattern. Again, you're assigning a number, but feel free to change your numbers as we go. Everything's relative here. Cooked potato. I think that is a little bit less than even the cooked carrot. I don't see any bubbles on top yet. Okay. Cooked mussel. Not cooked very well. I kind of went rare on this. Wonder what peroxide does to a keyboard.
Only one way to find out.
Been lucky so far. Okay, there are bubbles. There are definitely bubbles. But I would say slightly less than in the cooked ground beef. Like it's not like moving the beef up and down like it was as much. Potatoes still don't have any bubbles really to speak of on top. Cooked carrots, a little more. There's definitely some fine bubbles in there, but less so than the raw. All right, let's do liver. It's our last one. That's a lot. Bad experimenter. Okay, it's hard to tell kind of what's bubbles and what's chunks of liver disintegrating. But no like column of foam about to shoot out the top, right? Like there was with the raw. Like it's just I don't see anything on top. It's less than the beef for sure. I think it's maybe about where the carrots were. The cooked carrots. Okay, so there you have your data. Adjust your numbers as you see fit. Let's see if the liver still has if the raw liver still has the power to. Yep, sure enough. Okay. Oh, here's something. The test tube's warm all of a sudden. The reaction is producing heat. What does that tell you? What's the word for that? Gross. Gross is one word for that. What else you got? Allie? Exothermic, absolutely. Good, so now the rest of those questions are your job. What do we got for 10, 15 minutes? Work on those. I'll come back to you in a little bit. Make sure that equation's balanced. I'm going to wash my hands.